Hey there, everyone. Happy Monday. So, today we are going to do a little energy review. So, our learning objective is you will be able to properly identify and model the forms of energy and energy transformation. So, here we have a nice, handy dandy chart of the different forms and types of energy. So, feel free if you need to pause this video to write down notes, to draw your table if I'm going too fast. Never feel like you cannot pause this or rewind, because that is the beauty of this video, is that you can pause it and rewind and watch it at your own pace, okay? So we have our different forms and types of energies on the left side, and then on the right side we have some examples. So we have chemical energy, and we know that chemical energy is a type of potential energy, and so some examples are batteries, fuel, and food. So that energy is stored, and all of those things provide energy. So things wouldn't work if we didn't have batteries. Batteries feed whatever we need. Like my remote, the batteries are feeding. It's giving energy to my remote so that it will work. Car fuel feeds our car engine so that our cars can be able to go. Food feeds our bodies so that we can move our bodies and so that we can have energy, okay? Next, we have kinetic energy. Kinetic energy is if I'm jumping up and down, that's that energy of motion. And so an example is the running, jumping, skipping, hopping. Mechanical energy is also energy of motion, but I want you to think of gears turning. So like in my watch gears are mechanical energy. If you think of a clock, those gears. So mechanical energy and kinetic energy, they're both energies of motion. Electrical energy, that electricity is flowing through. So if you think of a toaster plugged into an outlet, that electrical energy is going from the outlet through those wires in the toaster to the toaster, and that energy is transformed into what? Who knows what that energy is transformed into? A toaster, into heat energy, that thermal energy. Okay, potential energy, that is that energy that is stored. So a ball at the top of a hill, that's potential energy. Thermal energy, it's boiling a pot of water. So that heat, that thermal, and we know the faster the particles move, that the when the temperature rises is when the particles move. So the faster they move, the hotter they are. So cold particles move slow. But the hotter they get, the faster the particles move, okay? Sound energy is musical instruments. So sound energy is going through this laptop in order for you to be able to hear Miss Brown's voice. If I'm playing a guitar, that's sound energy. If I'm listening to the TV, the stuff that's coming through the TV, that's sound energy, okay? So next we have, so now we are going to graph where potential and kinetic energy are at its greatest. So I want you to go ahead and pause this, and I want you to draw this graph on a sheet of paper, okay? So let's pretend that Miss Brown is about to go on a hike up a mountain. This is her mountain, and she is about to go on a hike. Miss Brown is going up the mountain, up the mountain, up the mountain, and now I'm at the top of the mountain. My potential energy is going to be at its greatest at the top of my mountain. So if I'm going to number this, I'm going to number this a 5. My potential energy is at a 5 right now. It is at its greatest, okay? And as Miss Brown goes down the mountain, that potential energy is becoming less and less and less. Because if you think about it, if you've ever been climbing, hiking, biking, when you go down the mountain, it's easier to go down the mountain than to go up. So my potential energy, my stored energy is decreasing. So this is going to be a 4, 3, 2, 1. And at the bottom, it's going to be a 0. And my kinetic energy is going to be at its greatest at the bottom. So if I'm labeling my kinetic energy is going to be 1, 2, 3, 4, and then at the bottom, my kinetic energy is going to be at the greatest. So as I'm going back up, Miss Brown is starting to slow back down because climbing up a mountain is hard. And so as I go back up the mountain, my potential energy kicks back in, and my potential energy is at its greatest form. So as I'm going back up the mountain, my 0 is going from 0 to 1, 2, 3, 4, and then at the top of the mountain, my potential energy is at its greatest. But what is our kinetic energy? As we go up the mountain, our kinetic energy is going back down. So it's going 4, 3, 2, 1, and our kinetic energy is at 0. Okay? Miss Brown has made it back to the top of the mountain, and now she is about to go down the mountain again. She is being very adventurous this day, okay? So Miss Brown is going back down the mountain, and she made it to the bottom of the mountain, and that is where my kinetic energy is at its greatest again. So if I'm labeling my potential energy, as I go down the mountain, I'm using less of my stored energy because I'm going fast down that mountain, okay? So I'm using less, so my potential energy is decreasing, and my kinetic energy is increasing. It's kind of small. All right, so remember, potential energy is that stored energy. You're not doing a lot of movement, but that kinetic energy, I'm running down that mountain. I'm running down, but potential energy, it's like I'm not even moving going up that mountain. And when I get to the top, I'm tired, I'm chilling, I'm resting, I'm storing all of my energy so that I can run down that mountain, okay? All right, next we have another chart. And so it says kinetic energy. Kinetic energy is the energy of what? What is kinetic energy? The energy of motion. Kinetic energy is energy of motion. Okay, so we have thermal energy, mechanical energy, and electrical energy. Now I see some of y'all like, some of these pictures they're not right. So let's see. I want you to pause this video and match the picture to the correct terminology. So we have thermal energy. So we know thermal energy is heat energy, and we see that thermal energy in a fire. Mechanical energy, that energy of motion. So that hammer, you have to move the hammer back and forth in order for it to push through that nail. And then electrical energy, plugging in that cord into the electrical socket, getting those electrical particles moving, that is electrical energy. Next, we have potential energy. And potential energy is the energy of stored particles. Stored particles, potential energy is stored energy. Okay, so energy of stored particles. Now I want you to pause the video again, and I want you to match gravitational, elastic, and chemical energy to their proper pictures. All right, so gravitational energy, we see that gravitational potential energy, they're bungee jumping off of a cliff. Would Miss Brown do this? No. But due to gravity, when they go off that cliff, that gravity is pushing them down. So all that energy that is stored on the person at the top, that gravity is pushing them down. And the higher you go, the more gravitational potential energy you gain. Elastic potential energy, we see that in the bow and arrow. When you pull the bow back, And when you store it, all that potential energy is stored in that elasticity when you pull it all the way back. And the further you pull back, the farther it will go. And then we see it in chemical energy. Now, The Simpsons is one of my all-time favorite shows, so any gifts that I can include from The Simpsons, I will. But we see that he's peeling a battery, but we see those electricity particles sparking as he's peeling the battery. Do not do this. Do not do this. But that electrical energy is stored in that battery, so when you plug it up to something, it works, okay? All right. So next, what does the law of conservation of energy say? I've been saying this, Miss Brown has been saying this in all the instructional videos, on all the classes. What does the law of conservation of energy say? Energy is never created nor destroyed because it is what? Always transforming. Good job. Good job. Okay, so let us look at our fire again. So we are going to go through the transformations, the energy transformations. So first, we have to place logs or wood to be able to burn the fire. So we place our logs and our wood down, and then we start the fire, okay? Next, we sit by the fire, and we're starting to get toasty. We even can make s'mores. So that fire is so hot, we're getting toasty, we're making s'mores. And then finally, it was so dark outside, I couldn't even see when I walked too far away from that fire. So let's think of the energy transformations that are happening. So let's read it back again. We place logs or wood to be able to burn the fire. Okay, so we fed the fire. Next, we sit by the fire and we start to get toasty. So we're warming up. We're able to melt some chocolate to make s'mores. Finally, it was so dark outside, I couldn't even see when I walked too far away from the fire. So the fire is providing us with some light. So now let's write it out as an energy transformation. So what was that first form of energy transformation that we noticed? What did the logs do? It fed the fire. And we know that food or fuel is an example of what type of energy? Chemical energy. Good job. Good job. Okay, next it said that we were starting to get toasty. We were able to melt some s'mores. So what type of energy was happening? What did that chemical energy transform into? Thermal energy. Good, good. And then finally, it said we were able to use the fire as light. So what type of energy is light? What did that thermal energy transform into? Radiant energy, also light energy. Okay, so that chemical energy was the source. We were able to get thermal and radiant energy because the chemical energy was the source. It was the food. It provided what we needed as our resulting energy. We wouldn't have the resulting energy if we didn't have the source. So that chemical energy was the source, and the thermal and radiant energy were the results, okay? So here is what I want you to bring to class on Monday. I want you to write this down, and I want you to bring your answer to class on Monday. What types of energy transformations do you see happening in your home? So we just talked about a fire. Last week in class, we talked about toasters, we talked about light bulbs, we talked about cars. I want you to look around because energy is all around us. It is happening all around us. I want you to look around in your home, where you go this weekend, whether you go to the grocery store, grandma's house, wherever you may go, and think of and look and write down an energy transformation and that transformation that you see happening around you. Then next, I want you to look at this picture. I want you to look at this picture. Do you predict that the cup will travel a short distance or a long distance? And I want you to answer this question, write it down, and bring it to class on Monday. And we're going to talk about it because it's going to lead into our lab on Tuesday. And I want you to explain why you think it's going to, or why you say it's going to go a short or a long distance. So these are your two tasks and your two materials, two answers, or three actually, three answers that you are bringing to class on Monday. A few reminders. If you have any missing work in Schoology, this needs to be done by Tuesday at 5 o'clock. Tuesday at 5 o'clock. We're going to do our lab on Tuesday, and so the materials needed for that lab are a ruler and a rubber band. And then do not forget, there will be a quiz on Wednesday. It'll be over the different states and forms of energy, energy transformations, and I'd highly suggest that you make study cards and put the vocabulary word on one. So like thermal energy on one and the definition on the other side. So heat and an example. So heat and a fire. For energy transformations, I'd highly suggest that you make index cards or write out different transformations that we've been doing in class. I've been telling everybody it's important that you take notes because it's going to pay off come quiz and test time. All right, guys, as always, if you have any questions, let me know, and I look forward to seeing y'all in class on Monday. Bye.